Okay, Assalamualaikum warahmatullahi wabarakatuh dan selamat tengah hari semua. Okay, jadi before this kita dah discuss on chapter 3 which is partial derivative, but before this we see about the topic limits and also the continuity of the limits. Okay, so now we want to move to the main business, which is the partial derivatives. Okay, so what is the partial derivative? Okay, let's see a few definition and also a few explanation here. The first derivative of a function of one variable tells us the slope of the tangent line at a given point. Okay, so we know that if we have a function, let's say we have a quadratic function on the graph. Okay, and before this we only deal with two variables, which is x and y. So if we are talking about function of x, okay, let's say our function of x is a quadratic function, therefore you have a curve like this, for example. And then every curve will have the tangent line, okay, where the tangent line touch one point on the curve, and you have many tangent line along the curve. Okay, so this tangent line we can find its slope, which is the gradient of the tangent line, by differentiating the function of this graph. Okay, for example, if this curve can be represented by the function f(x) equal to 5x squared minus 3x, for example, if you want to find what is the gradient of the tangent line of this curve, you just need to differentiate this equation. Then you will have f prime x is equal to 10x minus 3. So if you want the gradient of the tangent line at the point here, which is, let's say this is x equal to 7, we just need to substitute the value of 7 inside this. So you will have 10 times 7 minus 3, which will give you 67. So this is the gradient of the tangent line. Therefore, before this, when we are dealing with one variable, which is the function of one variable, which is only have x and y, okay, so the derivative of that function will tell us the gradient of the tangent line. Okay, but for a function of two variables, we deal with a surface. So I repeat this so many times in class. Now when we are dealing with three variables, which is x, y and z, okay, so we will have a function of two variables. For example, if you have z as a subject, you will have z in terms of x and y. So this one also called as a function of xy. So now you have a function of two variables. Okay, so when we have a function of two variables, means that we have at least three variables inside our equation. Therefore, we are dealing with the surface. Okay, so can you imagine the curve on the surface? Okay, I cannot show you the curve on the surface. Let's say we have a surface and we have a curve right here. Okay, this curve is floating. Okay, so if we have a tangent line, okay, if we have the tangent line of the curve, the tangent line is actually floating as well. You can rotate the tangent line. Okay, it's actually floating because it's not only plane x and y, is x, y and z, which is surface. Can you imagine if you have a ball, if you have a ball floating, a floating ball, if you have a floating ball, okay, now you imagine you have a floating ball, and at the bottom of the ball you have a tangent line. Okay, so you have a ball, right? It's float. Okay, it's floating. So at the bottom of the ball you have a tangent line touch the ball. Okay, as the ball floating, the tangent line is also floating, and you can rotate the tangent line. Okay, therefore if we pick any point on the surface, we couldn't find the slope because we have to pick direction. We need to know which direction this tangent line go, because if you rotate it, the gradient will be changed. Okay, if you rotate the direction, the gradient will be changed. Therefore, we cannot know okay, the gradient of the tangent line until we determine what is the direction of this tangent line. Okay, this is due to any point on the surface actually has infinite number of tangent line, because you have a surface. Okay, so every point on the surface has many tangent line because it can be rotated. Okay, it can be rotated. So in order to find a derivative in 3-dimensional, we have to specify the direction of the derivative. So, how to specify the direction of the derivative? What is the meaning of specifying the direction of the derivative? If you have a function of two variables, for example, you have a function of x and y, so you only have two direction here. Either it's in the direction of x or it is in direction of y. If it is in direction of x, you will get fx, means the f is in the direction of x. And if you want the slope to be in the direction of y, you will write it as fy. Okay, the first partial derivative of a function of two variables, which is the function of x and y, tell us the slope of the tangent line at a given point in either x direction or y direction. So this measure the rate of change of z with respect to x or the rate of change of z with respect to y. Okay, let me tell you something before we go further. We have a function z, okay, equal to x plus 2y, for example. This is a function of two variables. Why I say this is a function of two variables, even though you have three variables inside this equation, is because of this z can be written as the function of x and y. Okay, same goes to when we have two variables only in our equation. Let's say we have y equal to 5x power of 3 minus 2. You can see that this one is only, you have only two variables. Why it become the function of one variable? Because the y, you return it as a function of x. You rename it to be a function of x, which is 5x cubed minus 2. So this is the function of one variable. When we have three variables, this is the function of two variables. So when you have one variables, when you have a function of one variables, I just want to repeat it. Okay, if you have function of one variable here, you differentiate this function, you will get f prime x, and you differentiate this equation, you will get 15x to the power of 2 minus 0. This is the slope of the tangent line. Okay, but if you have this function, let's say you have fx square, fxy equal to 5x cubed minus 2y square minus 3. So now you see, in your equation, you have x and you have y. So you want to differentiate y. You want to differentiate x or you want to differentiate y. You cannot differentiate both at the same time. That's why, in order for us to differentiate the function of two variables, which is in order for us to find the slope of the tangent line when it is involved two variables function, we need to decide in what direction we want that tangent line to be. Okay, if we want it to be in the x direction, we will differentiate this function in terms of x or with respect to x. But if we want it to be in the y direction, we will differentiate this one with respect to y. Okay, you might ask me, Doctor, how if y is a subject, not z? Now z is a subject, y is a subject. For example, y equal to 3x cubed minus 5z. So this also can be written as the function of x and z. 3x cubed minus 5z. Therefore now, if you want to find the slope of your tangent line, you need to decide the direction, but the direction is no more x and y. The direction is either in the direction of x or in the direction of z. That doesn't matter. Okay, the matter is, the most important thing is you need to know when you have a function of two variables, for you to find the slope of the tangent line, you need to differentiate the function. But the problem is you have the equation in two variables, so you want to differentiate in terms of what? So you need to decide. If you want to differentiate in terms of x, therefore we only differentiate x, and this one we consider it as a constant. If you want to differentiate z, okay, you can only differentiate z, and the rest is a constant. Okay, so the idea is to get the slope of the tangent line, or to differentiate the function of two variables. The first thing that you need to decide is in which direction you want the tangent line to be. Alright, so now, okay, let's see what is the derivative of the partial derivative of the function of two variables. Why it called a partial derivative? Because you not differentiate the whole equation, you only differentiate the equation partially. Okay, separuh, depends on what is the direction that you choose. Okay, for example, okay, sorry, this is not example, this is explanation. If z equal to the function of x and y, now you have the function of z is equal to the function of x and y, then the partial derivative of the partial derivative of the function f with respect to x and y respectively is defined by fx xy equal to limit delta x minus 0 fx plus delta y minus fxy divided by delta x, and the vice versa. But this is not really important, guys. Why? Please thoroughly see this this formula. This is actually called as a first principle of differentiation. Okay, you don't need to remember this. This is only the first principle of differentiation. What this equation try to tell you is, if you want to differentiate in the direction of x, your equation now have two variables x and y. If you want to differentiate in the direction of x, you only need to differentiate x, and the rest including y is constant. And if you want to differentiate with respect to y, okay, you choose the direction is in the direction of y, so you only differentiate y, and the rest of the equation including x is a constant. Alright, for the partial derivative of a function of two variables, the function of two variables fxy will determine the partial derivative with respect to x by regarding y as a constant. So when you differentiate with respect to x, you will get fx. This one is the meaning of differentiation of partial derivative in the direction of x. So when you want to differentiate x, you will consider y as a constant. Similarly, if you want to differentiate y, okay, you will let the x to be the constant. Okay, so similarly, the partial derivative with respect to y is found by regarding x as the constant while differentiating with respect to y. So if you want to find the derivative in the direction of y, then x is constant. If you want to find the direction of tangent line in terms of x, then y is a constant. So this is the example. Okay, the process of differentiating a function of several variables with respect to one of its variable while keeping the other variable fixed is called a partial derivative, because the partial differentiation and the resulting derivative is a partial derivative. Okay, class. If before this we have the equation of one variable, for example, you have fx equal to 5x cubed minus 2x squared minus 3. Then if you want to find the derivative of this function, you just need to differentiate the whole equation here. 5x cubed, that is 15x squared. Negative 2x square, we have negative 4x minus 3 is equal to 0. So this is called as a partial derivative, and the process of differentiation is called as a partial differentiation. Why? Sorry, this is not partial, this is one variable. So why this one variable is not called as a partial? Because you see, you differentiate everything in the equation, the whole equation. But if you have the equation of two variable fxy equal to 5y cubed minus 2y plus 3x squared minus 3x. Okay, so now you want to find the derivative of this one. So if you want to find the derivative in terms of x, so the symbol is x, small x here. And what you do is you only need to differentiate the x. Y will remain as a constant. Therefore, this is called as a partial derivative because it's not involved the whole equation. It only involves a part of the equation. That's why this process is called as a partial derivative. Okay, so now notation for the first partial derivative. So if you have the function of x and y, which is the function with two variables, then the partial derivative of the function f with respect to x and y respectively are denoted by, so this one is the partial derivative. If you nampak macam ni, maksudnya partial derivative in what direction? X direction. If you nampak macam ni, this one is partial derivative untuk apa direction? Untuk y direction. So bila x direction, y akan jadi constant. Bila y direction, x akan jadi constant. So saya nak tengok terus kepada example. Kalau tak, awak tak faham. Okay, so let's see this example. We have the function of xy equal to 2x cubed minus 5x squared y squared plus 2x minus 4y. Find the partial derivative fx and fy at 1, 2. So fx here means the first derivative in the x direction. So you need to remember that if the derivative is in x direction, y will be constant. So now you need to differentiate this one, 2x cubed, differentiate, you will get 6x squared. This one, you have this one as a constant. Let's say all y you put as a. This one is also a because dia constant. The whole sebab ni kan, ini kan nombor. So semua ni adalah constant. So sekarang apa yang kita kena differentiate? This one sahaja. 2x kuasa 3 jadi 6x. Negatif 5x kuasa 2 jadi negatif 10x y square. Kerana y square ini adalah constant. Seolah-olah macam awak ada macam ni. Negatif 5a x kuasa 2. A ni tadi adalah constant. So kita biarkan dia kawan dengan 5. Okay, jadi 2 bawa pergi depan, dia jadi negatif 10ax. Okay, negatif 10 darab dengan a darab dengan x kuasa 2 kuasa 2. Okay, and then you differentiate 2x, you dapat 2. Kenapa kita tak differentiate this one? Kerana dia adalah constant. Differentiate constant, you will get equal to 0. Lepas tu dia nak awak cari derivative pada point 1, 2. So you just need to substitute the value of x equal to 1, the value of 2 equal to 2 inside the equation. And then you will get the slope of the tangent line for function with two variable will be negative 32. Okay. Let's see this example. Okay. So if fsy again is the same function 2x cubed minus 5x squared y squared plus 2x minus 4y. So just now we already find the derivative in the direction of x. Now we want to find the derivative in the direction of y. So whenever we want to find fy, we will consider x as a constant. Okay, so let's write down the equation. We have fxy. This one is the function of two variables, which is 2x cubed minus 5x squared y squared plus 2x minus 4y. Okay, so now we want to differentiate with the direction of y. So remember, x will be constant. So everything that have only x will be a constant. So this one, the first one here is only x. So this one is whole a constant. Okay, so when you differentiate constant, you will get equal to 0. So there's no more here. So you want to find fy, right? So this one is 0. Okay, the whole thing here is a constant. You only need to differentiate y. So how to differentiate y? The power you multiply by the constant. So 2 darab dengan 5x kuasa 2, you will get negative, right? Sini negatif, negatif. 2 darab 5x kuasa 2, you get 10x kuasa 2. Y kuasa tolak 1. So this is the differentiate. You tak kacau pun x. X ni adalah constant. Okay, this one you only have 2x, right? So the whole thing adalah constant. Differentiate constant sama dengan kosong. Now you have y. So differentiate negative 4y, you get negative 4. Because we now find the derivative in the direction of y. So we only consider y. So you have your fy equal to negative 10x squared y minus 4. Now you want to find the derivative at x equal to 1, y equal to 2. So you just need to substitute. So you will get negative 10, 1 to the power of 2 darab dengan y, which is 2 minus 4. Okay, so 1 kuasa 2, 1 darab 2, 2 darab negatif 10, negatif 20 tolak 4, negatif 24. So this is your fy. Okay, let's next example. If the function of xy, which is the function of two variables, is equal to y to the power of 5 ln x, find the partial derivative, which is fx and fy at point 2, 2. So remember, fx is the derivative in the direction of x, means y is a constant, and fy is the derivative in the direction of y, means x is a constant. So now we have fxy equal to y5 ln x. Okay, so you want to find fx, right? So you will need to differentiate this one because y5 is a constant. So constant tulis je balik. Ln x differentiate dapat apa? Dapat 1 per x. So what you have here is y to the power of 5 divided by x. So y awak, ni lah di fx awak. Okay, sekarang kita masukkan nilai y2, x2. So 2 kuasa 5 bahagi 2. So 2 kuasa 5 adalah 32. 32 bahagi dengan 2, you will get 16. Betul tak? 2 dah 2, 4, 4, 8, 8, 8, 32. So dapat 16. So now you want to find what is the derivative in the direction of y. So in the direction of y, your x will be constant. So this one is constant. No need to do anything. You just need to write it back because it's a constant. Now we just need to differentiate this one. 5y to the power of 4. So this is your partial derivative because we only differentiate y. We are not disturbing x. Okay, so substitute the value of x equal to 2, y equal to 2. So what you will have here is 5, 2 to the power of 4 ln 2. So 2 to the power of 4 is 16. 16 times 5 is 80, I think. 16 times 5 is 80, right? Okay, 80 ln 2. So you can calculate with your calculator. 80 ln 2 is about 55 something, I think. 55 point something. Okay, just check what is the value of 80 ln 2. So this one is your partial derivative in the direction of y at point 2, 2. This one is your partial derivative in the direction of x at point 2, 2. Okay, let's see another example here. Okay, let me erase everything so that we can do it together. Okay, I erase x. Okay, class. Determine the partial derivative with respect to x and with respect to y. So it means that in the direction of x and in the direction of y. Evaluate each of them at point 2, -1. So first we need to find the partial derivative, which is fx, and later we will find fy. So this is the function, and the function is in the term of quotient or fraction. Okay, so for you to solve the equation that is in the term of quotient or fraction, you need to use the quotient rule. What is quotient rule? Let's say we let this one is u, this one is v. So quotient rules is v du minus u dv divided by v square. Okay, so what is your v, what is your u? You need to list down. So your u is 2xy, your v is x plus y. Now you need to ask yourself, you want to differentiate in what direction? So you want to differentiate in x direction, therefore y is a constant. So what is your du? Y constant, guys. Y constant, guys. Just write it back. Differentiate to x, you get 2y. Y constant, guys. So differentiate y, will get 0. Why this one you write down, but why this one is equal to 0? But this one is this one is not eliminated. I mean, this one is you bring it down, because you see in between of this function is multiplication. Okay, in between of this all function is multiplication. For example, macam awak ada macam ni lah, 2x kat belakang ni 3 constant. So 3 ni awak boleh darab dengan 2, dapat 6 kan. Okay, sama lah, cumanya 2 dengan y ni tak boleh darab walaupun y ni constant, sebab dia dalam bentuk variable dan number. Kalau macam yang ini, contoh dia macam x tambah 3. So kalau you differentiate, 3 ni dapat kosong sebab dia constant. Betul tak? So y ni jadi constant, so dia dapat kosong. Differentiate x dapat 1. So v prime ataupun dv adalah 1. And then apa yang kita kena buat, kita masuk je lah dalam formula. Okay, formula dia v darab du. So v kita adalah x tambah y, du kita adalah 2y, minus u darab dv. So u kita adalah 2xy, dv kita adalah 1. Okay, so x darab dengan divide by, jangan lupa, v square. So your v square is x plus y kuasa 2. Okay, and then you expand, you will have 2xy plus 2y square minus 2xy divided by x plus y kuasa 2. So this one and this one boleh potong. So you just left with 2y square divided by x plus y kuasa 2. So what you need to do is now substitute. Your x is 2, your y is negative 1. So you have 2 to the power of 2 divided by 2 plus negative 1 to the power of 2. So 2 to the power of 2 is 4. 4 times 2 is 8. Okay. 2 plus minus is minus. 2 minus 1 is 1. 1 to the power of 2 is 1. So you have 8 as your answer. And then you can try to do fy, which is the partial derivative in the direction of y. Okay, and also one last question here. For example, I already wrote the answer, but you can try yourself and check whether you get the same answer with me or not. Alright class, see you in the next class. Bye. Assalamualaikum.